Average value.
So we're going to show you something kind of interesting about average value and how it works. So when you think of like average value, it's basically the average of all the values on a certain function. So like if you have an f of x, what is the average of all the values on that function? So I was just kind of playing around with how this works the other day, and I found something kind of interesting. So if you have, let's say that velocity equals v of t, and position equals x of t, right? Right?
Yeah, that's fair.
Okay. And you want to find the average value of velocity, right? Let's say that's a question that they ask you.
Okay.
So you would have, let's see, 1 over b minus a times the integral from a to b of v of t dt. What? No, it's that. That's right.
Tell me what B and A is.
B and A are just the interval of time values that they give you. So they'll say like the average value on the interval 3 to 5 or whatever, right?
Yeah, 3 to 5. And which one would be the B and which one would be the A?
Well, A would be the lower one.
Yeah.
And B would be the higher one. So, here, wait, stop.
Alright.
So here's the interesting thing that I found. So if you evaluate this integral right here, right, you're going to end up with x of t because it's a position. The integral of velocity is position. So you have x of t plus c evaluated at b and a. Is that fair to say? And the whole thing is times 1 over b minus a, right?
Yeah.
Because we're still looking for average value of velocity. We're just evaluating this.
Mm-hmm.
So then the c obviously goes away because when you evaluate the integral, the c goes away. But what we're going to have is we're going to have 1 over b minus a times x of b minus x of a.
Boom.
But then, does this look a little bit familiar? It should. It's x of b minus x of a over b minus a, otherwise known as average slope.
That's too cool.
So basically what we just did there was, if we're looking for the average value of velocity, we're looking for the average slope of position, the average rate of change of position, right? Because this gives us the average rate of change of position, which is velocity, right? Because if you take the derivative of position, you get velocity. Does that make sense?
Yeah.
So, yeah.
That's it?
Yeah, that's all. I just wanted to kind of show how the average rate of change of position is the same as the average value of velocity. We just evaluated the integral, and we saw that it's actually the same thing.
Sounds good. What's the other thing? The average.
Which one?
There is like average. This is average value.
Yeah.
The other one.
Average rate of change?
Yeah, that was just slope, right?
It's the slope of the secant line between 2 points, which is what we just found here.
But that's only.
That's for.
You can just directly.
That's the average value of the derivative.
So just like the slope of the velocity.
Yeah.
Okay.
No, not the slope of the velocity. The value of the velocity. Do you get what I'm saying?
Wouldn't it still be like VB minus VA over?
No. That would be the value of acceleration, the average rate of change of velocity, which is acceleration.
How would you do the average?
The average rate of change of velocity?
Yeah.
That would just be v of b minus v of a over b minus a, and that would be.
But that's what I just said.
Yeah, but this would be average acceleration, or average value of acceleration.
Okay.
Do you get that?
So what is the other thing we're talking about?
That's it. That's all we were going to say.
But that's what I just said though.
What do you mean?
I said the average rate of change would just be VB minus VA over B minus A.
Well, that's the average rate of change of velocity. Yeah. So there's average value of velocity and average rate of change of velocity. And average rate of change of velocity is the same thing as saying average value of acceleration.
So technically, I can say that this. Where's the laser beam? I want to be laser. So we can say that this is the average rate of change of position.
Yep, average rate of change of position
An average value
of velocity, which is equivalent to this, actually equivalent.
Okay. And this is the average value of
Of
acceleration
and average rate of
change of velocity. Okay. Okay, I got it.
Cool.